does HFE or the adult type of hemochromatosis exist in India? Because we are not going to, this is a predominantly pediatric or pediatrician audience, and therefore we are not going to talk, let me clarify that we are not talking about neonatal hemochromatosis, which is a very different disease except that they share the word hemochromatosis. Some of my slides would be an overlap, can't avoid that. So hemochromatosis can be defined as a progressive increase in iron content of the body, leading to systemic iron overload of parenchymal cells, in particular the liver cells, and eventually to disease of several body organs. You've seen this slide, so I'm not going to spend more time, except that even if you have 1 milligram of excess iron absorption every day, over a 10-year period, you are going to absorb 4 grams extra, a bit like just 20 extra calories every day lead to weight gain, which is what our population is trying to fight today. So, and that is equal to the total body iron that each one of us has. So just that small increase, which was referred to by Dr. Mistry, would lead to a marked iron overload. And all this goes on. So iron overload can be either primary or secondary. Again, I'm not going to spend time on this because that has been discussed already. So when we come to this adult onset hemochromatosis, we are talking of diseases because of defects in several genes. Of these, in the West, in the Caucasian population, upwards of 95% of disease is because of this gene called as HFE gene. Some of the cases are because of mutations in transferrin receptor 2 or hepcidin antimicrobial peptide gene or in hemojuvelin gene. The abnormalities in these two genes cause disease earlier in life, the so-called juvenile hemochromatosis. So early onset, disease is severe, and there is very little contribution of environmental factors in this disease. On the other hand, the HFE gene defects lead to problems later in life. These are milder, so much so that a large proportion of those who have genetic defect never manifest, and there is a large contribution of environmental factors, that is iron intake and factors that can cause increased iron loss. And this is what we are talking about. Of course, there are cases which have mutation in these genes as well as mutation in these genes, say heterozygous forms, and then you get an intermediate phenotype. Again, some overlap with Dr. Mistry's talk, but if you look at the populations which are predominantly of Caucasian race, if we see in these studies, the prevalence of homozygotes is roughly 1 in 300. And if we translate this to allele frequency, which can be done easily by taking a square root of this, we have a gene frequency of about 5 to 7% of the chromosome 6 in those populations have the abnormal gene, that is the gene with Y amino acid rather than C. How do data in India look? Let's first look at the clinical evidence. You've already heard Dr. Desai telling us that in his long career of 50 years, a very active career, he's seen only 3 cases. And a similar thing is true for most of us who look after patients with liver disease, though for much fewer years. So most of us have seen 0, 1 or 2 cases, as would be expected from that number. However, that could be because iron deficiency is so frequent in our population. So if people are not ingesting sufficient iron, even if the proportion of iron absorbed is higher, maybe the disease does not manifest. And hence we need to go to genetic studies. For this talk, I did a systematic survey of literature, and the studies that I could come across in normal Indian population published from India. So I have not included the study that you saw on Dr. Mistry's slides. We see that among healthy people, that's the number of subjects, number of total alleles being twice the number of subjects. In all these studies, only one study reported one person with heterozygous C282Y mutation, giving us a gene frequency of 0.03%. Roughly 1 in 1,000 alleles were mutant. That's very low compared to about 6% in the Caucasian population. There are several studies available for groups which are otherwise at risk of iron overload, that is those with thalassemia, somewhat higher but still much lower than that reported from the Caucasian populations. And here I must point out, for those of you who are familiar with lab techniques, these are all 6 in one study, nothing found in other studies. This was an early study that used sequence-specific primers, and using PCR, which is based on sequence-specific primers, there is a greater possibility of ending up with problems. No sequencing data are available. Even in the study that I referred to earlier, again, this was based on sequence-specific primers. Among liver disease patients, mostly liver cirrhosis, except this one study in non-alcoholic steatohepatitis, small number of subjects, and this one specifically enriched for those who have high iron content. We find again only one positive, again based on PCR-RF, no data based on sequencing. If you combine these 3 types of data, we have a gene frequency of less than 1 in 2,000 alleles. The other mutation in HFE gene that causes iron overload, though not adequate to cause hemochromatosis, that mutation is commonly present. 5% of healthy people, about 7 to 8% of those with thalassemia and liver disease who have been investigated. Now let's come to the clinical situation. In liver disease, people have looked for iron overload. From Delhi, from GB Pant group, 10% of those with chronic liver disease had transferrin saturation more than 60%, but none of these had C282Y mutation. Chandigarh, 23 patients with NASH were investigated. There were 31 patients, but in only 23 they looked for transferrin saturation. Only 1 had it high. They also did biopsy in 14 people. None of them had level 3 or level 4 staining for iron. Other studies, again, one from Delhi, one from our institution, the proportion of iron overload was very low, and none of these people had C282Y mutation. So when we, a few years ago, had 2 patients, SIBs, with, who had iron overload, primary, no secondary cause found, we looked around for other cases of iron overload. We could get one from our records whom we recalled, and we wrote to several hepatologists, and we could get blood specimens from 2 others here in Mumbai from Dr. Sudeep Shah. And when we investigated these 5 patients, all of them had classical clinical features. They had high transferrin saturation. They had high serum ferritin. They had all undergone liver biopsy showing large amount of iron deposit. Many of them had undergone phlebotomies, several proving that they indeed had iron overload and they did not develop anemia after a few phlebotomies. When we did PCR RFLP for C282Y mutation, all 5 of them had normal C allele, not even one Y allele. When we looked at them further, one of them had homozygous H63D mutation. However, we do not believe that this was responsible because his sister, who was one of the 5 persons, did not have that mutation. And none of them had previously known other mutations in the HFE gene. We did sequencing of all the 6 alleles, nothing anywhere, except that of these 5 patients, 4 had an abnormality at a splice site, but the problem is that these 2 who were SIBs, one had that and the other one did not have that, indicating that these 2 SIBs did not share their chromosome 6, even one of those. So that cannot be the cause. We looked for mutations also in the hepcidin gene and ferroportin, though we didn't look at the entire gene, we looked at the known mutations till that time, and none of them had any of those mutations. How do our data compare with others? This is a study published about 2 years ago. They looked at 8 families with similar features as ours, and they found mutations in hemojuvelin genes, hepcidin, and ferroportin. So, to answer the question in my last slide, iron overload, do we see it in India? Yes, occasionally, but very rarely. Again, we had that right from even before my talk, that's very infrequent. C282Y mutation, yes, there are a few reports, but it's very infrequent, and those reports, none of those has been confirmed by sequencing, and we still have data based on techniques which are not very good. We did have this, 5 of these patients have had the entire C282Y mutation looked at. Not only that, the entire HFE gene looked at and no mutation was found. So even these iron overloads, a few that we see, do not appear to be because of C282Y mutation. Therefore, I would propose, given this vast experience, I don't think we really need to bother about this disease, and a large number of testing for iron overload that we are doing in our patients with chronic liver disease, thinking that we would find this cause, I think is not really needed. Thank you.